It's such a sad rainy day outside. I guess there's nothing else to do but stay inside and talk math. All right, let's get started.
Okay, everybody, we're starting to get into some algebra now, which is really exciting, and I hope you're excited about it. I am. Today we're going to talk about variables and expressions. Now, quickly, I want to give a quick little definition for you. So if I gave you the problem 7x plus 5, this is an example of an expression, okay? An algebraic expression contains one or more variables and may contain operation symbols. So like plus is an operation symbol, okay? What's a variable? Well, a variable is the x. When you have a letter that represents a quantity that can change. Okay, let's get into it. So here we have a chart. And if you're following along in your book, you can find this chart on page 50 in chapter 2. Okay, but this chart shows you that something that cost $1 in 1950 in 2015 would cost you $7. Okay, in 1950, if you spent $2 on an item, today that same item would cost you about $14, and so on. $3 in 1950, $21 in 2015, or in today's time. Okay, down here we have a blank, and I'm going to put a P there for price. That's our variable. Could I have used C for cost? Yeah, sure I could. There's no problem with that. Okay, but over here in our blank, since I'm just giving you a variable P, over here I need an expression. Okay, and I know that to get from $1 to $7, that's times 7, or plus 6. But to get from $2 to $14, 2 plus 6 is not 14. So that's obviously not right. But 2 times 7 is 14. 3 times 7 is 21. So our algebraic expression would be P, the price in 1950, times 7. Okay, let's keep going. Here's some examples of some expressions or translating between words and math. If you have x times 3, well, that's kind of confusing with the multiplication symbol and the fact that we're using x. Instead, you could use x times 3, which is x dot 3, not a decimal. Okay, it's up here. You could use x times 3 by putting the 3 in parentheses, or you could just put 3x. And if you have the number by the letter, that means that you're multiplying. Down here we have 35 divided by y. Well, you could also do that as a fraction, 35 over y. This would be less known, but the slash 35 slash y also means 35 divided by y. Okay, now let's keep going. Now we're looking at, we have b, which is, in this case, 10, 16, or 17. And then over here we have our expression. So we have our variable, and it gives us some numbers we can use for our variable. And then over here we have our expression, 2 times b minus 3 squared. Okay? So what we're really looking at is 2 times 10, because I'm going to put the 10 in for b, minus, and 3 squared would be 3 times 3, so we have 9. Obviously we have to do the exponent first because of PEMDAS, and there's no parentheses, so we did 3 squared first, we got our 9. Then we're going to do our multiplication, so 2 times 10 is 20. 20 minus 9 gives us 11. Okay, let's try this one. 2b minus 3 squared. If b equals 16, we have 2 times 16 minus 3 squared, which I know is 9. Then I have to do 2 times 16, which is 32. And if I subtract 9, that gives us 32 minus 10 would be 22. Take that 1 away for 9, 23. Okay, let's do one more. 2b minus 3 squared. If b equals 17, you have 2 times 17 minus 3 squared, which again, we're going to do that first because of PEMDAS, our order of operations. 3 squared gives us 9. Then we have to do our multiplication. Sorry, technical issue there. You may not have noticed, but I had a little problem, but we're going to keep going. Okay, we have 3 squared gives us 9, and then we have to do 2 times 17 next, because in PEMDAS, or order of operations, multiplication would come next. That gives us 34 minus 9. Okay, simple subtraction problem, and we're going to end up with 25. Okay? Hey, I'm throwing you a curveball. In fact, I even drew you an awesome picture of a student looking at some homework and saying, yay, because I know you're that excited. Trust me. Okay, I want you to look on page 55, and there's a chart there. I want you to read through the chart on page 55 to see the different ways to write math expressions with words and symbols, and we're going to talk about that tomorrow. I'm throwing this in the middle of the presentation just to see if you're paying attention. Okay, we're going to talk about writing expression for the sequence in the table. Okay, we've got our position up top. We have 1, 2, 3, 4, 5, and n. And down below we have the value. Okay, we have 3, 5, 7, 9, 11, and then we have a blank space where we need to write our expression. Okay, look for the relationship between the positions and the values of the terms in the sequence. Let's use guess and check. Okay, well, if we were going to guess 2n, well, in our first example, if we wanted to use number 1, 2 times 1 gives us 2. So 2n doesn't work. Okay, it just doesn't work. 2 times 1 equals 2, not 3. Okay, let's do 3n. 1 times 3 does equal 3. So that works for our first position. Let's try our second position. 3 times 2, I'm putting in the 2 for the n. That gives us, 6. That doesn't work. It doesn't work for 5. Okay? So obviously 2n is too low. Doesn't work. 3n, too high. Okay? Let's try this. Let's try 2n plus 1. Now if I substitute in 3, or excuse me, if I substitute in 1, will that give us 3? Let's find out. 2 times 1 equals 2, plus 1 equals 3. Okay, so 2n plus 1 does work, but when we tried our last number, it also worked one time. Let's see if it keeps working. 2n plus 1. If n equals 2, 2 times 2 is 4, plus 1, that does equal 5. Okay, well, let's check again. 2n plus 1. If n is 3, 2 times 3 plus 1, that gives us 6, plus 1 equals 7. Okay, and I think if you would check the next two, you'd find that we're good to go. So here we're looking at 2n plus 1. And if I had a little more room, I'd write it like this. 2n plus 1. Okay, very cool stuff. I want you to look at that page, page 55. We're going to talk about it tomorrow. Have a good day.